Hi, I'm Bruce Clark, General Manager of AI-TEK. For over 50 years, AI-TEK has been providing reliable, predictable, cost-effective monitoring and control devices for some of the most demanding speed sensing applications on planet Earth and off. AI-TEK started life as AirPaks, a small industrial division of Fortune 100 companies. We are now privately owned, boasting all of the quality systems of those larger companies and the personal service and entrepreneurial spirit found in the best small companies. We are AS9100 ISO 9001 certified, and our sensors are made in the USA. I hope you will find the following training helpful in gaining insight into AI-TEK, the company, its products, and numerous applications we serve. Thanks for your interest in AI-TEK. Welcome to the AI-TEK Instruments Profile Training Series. This is, we're covering tachometers and accessories. Our tachometer product, they're highly configurable instruments that provide a measuring, monitoring, and control to critical equipment. And they allow you to, they read the speed sensor signal and then convert those signals into units and functions that are relevant to the user. So it's more than just a speed device. It allows you to calculate things. It allows you to do rates and percentages and convert. It's not just about RPM. It can be about gallons per minute. It can be about a lot of different things. And so, the tachometer can be a powerful instrument. They're also used they're not necessarily in primary speed control, but they're used for backup as well. So if you have a system where you have a primary speed system, let's say on a turbine, you may want to be able to shut that equipment down, and a lot of those systems require a redundant system to their primary control in order to make sure that that happens. So that's where the TAC can come in as well, because it's not integrated with the main system at all, and it provides that safe control and safe shutdown. All right, so if you look at the TACs, we have two different tachometers. There's three boxes there, but we'll start with the first one, TAC Troll. If you look, a TAC Troll, the troll part indicates that there's a display. The TAC Pack indicates that there is no display. It's at this point it's a DIN rail mounted box, and there are terminals on the side, but there's no display. There's no front key panel on it. Okay, so there's also different up and down optioned versions. So the 10 is the down option version, the 30 is the up option version. When you're reading the list, the black print exists in both. It's specifically the low, but it's in both. And then the red print it describes the options that are available on that up optioned version. Okay. So for a TAC Troll, it's a panel mount device. Has a display and a keypad on the front panel. So it's got the LCD display. It's got it'll run off of AC/DC power. There are two mechanical relays on the 10 version. There's the USB connectivity on the 10 version, infrared remote compatible. There's a little sensor here, and so if this is buried inside of an enclosure or something like that, you don't have to take it out of the enclosure, and you can use the infrared remote to make those changes. And it is remote display compatible. We'll talk that about in a minute, but that's our TAC Troll Plus. When you up option it, you get utility RS-45, which is essentially a parallel connection to the USB. It just allows, instead of you're being on a 10 or 15 foot leash, now you can go thousands of feet out, and it allows the tachometer then to communicate to a control room or something like that. That's a great distance away. There's an analog output with the up option 30 version, and there's also an addition of two solid state relays. So on top of the two mechanical relays that you get, it also has solid state relays. Then they are programmable from the front panel or via the TAClink software that we provide with every tachometer. If you have a TAC Pack, essentially it's the same device. Back in the day, our TAC Packs and TAC Trolls, they had different microprocessors. They were programmed differently. The programming methodology was different. You couldn't share programs because they were just simply entered with buttons and thumb wheels and that kinds of things. So right now, if you created a recipe or a program for a TAC 30, then you can load it into a Tac 30 and it'll run fine. And so the TAC, no display, no keypad, mounted on DIN rail, runs off the same AC/DC power, mechanical relays, USB, and remote display compatible. And again, it adds the RS-485, the analog output, solid state relays. Okay. Now, in programming this device, since there's no keypad, obviously that's not one of the options here. So the only way, there's two ways to program it. One would be via TAC-Link, which I highly recommend, or you can use the Tactrol Plus. So the Tactrol Plus is not a tachometer. It is a remote display, really. And that remote display, it takes the signal directly from one of these tachometers. So it comes with a cord, and it can plug into either TAC or Tactrol. It's powered through that connection, and it receives serial data through that connection. The Tactrol Plus then becomes an extension of that device, and it can be multiplexed up to 8 displays in total. So if you have a TAC, there's no displays on it, and so you can have up to 8 Tactrol Pluses, and in installations where you might want displays in multiple rooms, that's the perfect way to do that. You just multiplex it. In the old TACs, there was an analog output, and then there was like a 0 to 1 meter driver, and this really kind of takes that place. We didn't do a 0 to 1 meter driver in the TACs, but so now instead of something that has to be calibrated and maintained and everything, the Tactrol Plus now gets its information serially, so there's no calibration issues, and you can do your programming from it. You can apply security to it, so you actually can't do programming if that's how you select it, and you can really pull anything about the TAC from any one of those installations if you set it up that way. Right? It can also then be used as a programming pendant. So for TAC, let's say maybe you didn't want to use TAC-Link. You're not going to have a laptop available or whatever. You can get a Tactrol Plus, put that in your toolbox, and then that can become the way you pull and program the TAC. So either way, 3 instruments, 2 of them tachometers, and 1 of them is a remote display. When you buy these, the basic units, you see a panel mount again for the Tactrol and a DIN rail mount for the TAC. This green device in the back, this is really just showing it's not something that comes with it. It's a power supply, and it allows the power supply kit comes with a DIN rail adapter that snaps down into the DIN rail. And what that allows is that the power from the power supply can be directly connected to the TAC without making any external wiring connections. It's all done through that bus. So it's really just shown, if you want to use that power supply, you don't have to run any external wires to get it powered up. All you need to do is hook up your sensor or whatever other functions that you're connecting to. So beyond the standards, you have both of them have a NEMA 4X option. So this is going to be a box that keeps out moisture, keeps out dust, keeps out pretty much everything highly, for wash downs on equipment and that kind of thing. If you move over to the right, the AI-TEK's explosion proof. There's 2 different boxes here, and there's a window in this one because there's something to see. There's a display on the Tactrol where there isn't anything really to see on the TAC, and so we use a different box. This one's a little bit cheaper because it has a simpler lid to it. But anyway, so it's AI-TEK's. Actually, it also does, I believe it's AI-TEK's, ICEX rather. So it encompasses pretty much all of the prevailing protection strategies we talk about for the sensors. But here, the tachometer doesn't have that intrinsically built in, but by virtue of the fact you're putting in a box, it takes on those properties. So some of the features, they're programmable and highly configurable. So, you're not just stuck with a tachometer that's going to measure speed. You can do a lot with it. Every tachometer shipped with TAC-Link. I highly recommend using TAC-Link. TAC-Link allows you to, program. It allows you to store the program so that if you have, let's say, multiple TACs, you can develop it once on one and then just simply reprogram, or if for whatever reason you need to replace it, you can you can maintain the TAC or the program, revision controlled or whatever, backed up, and then you simply, you can just load it into successive tachometers. All right, each one has 2 sensor inputs. Both the TAC pack and the TAC-Troll models take 2 sensor inputs. All of the tachometers do mathematic functions. Both TAC pack and TAC-Troll, they have selectable list of equations. So what they do is, the input comes in, it's frequency, it's cycles per second. And so that doesn't really mean much to most people, and so it allows you to do some math. You can compare the 2 signals, you can really make the display talk in the units that are important to you. Both of them run on AC and DC input voltage. So the old ones, you had to have a separate, model for AC and one for DC and the whole bit, but it doesn't matter. They both run on both. You can use the DC as a backup, put a UPS on there, and that's your uninterruptible power supply for in case the AC fails. Analog output, both of them are available with analog output, and they have 3 ranges. The 2 traditional ones being 0 to 20 and 4 to 20, but we also offer a -20 to +20 milliamps. In the event that you want, have a device that needs to be driven negative, this range is the full range of the analog output and allows you to do that. Both of them have programmable relays. The mechanical relays are available in the down option, the 10 versions for both TAC-Troll and TAC pack, and then they offer the not only the mechanical relays, but then we add on solid state relays. So the solid state relays are there because they can switch faster. They don't switch quite as much current, but they can switch faster, so response times go down, and in certain critical applications, the saving of a couple of microseconds or milliseconds can be the difference. A better choice in those applications than a mechanical relay. The mechanical relay, that's still the workhorse, that switches a lot of current and a lot of voltage, and so those are used in more traditional applications where you can stand a little bit more delay. The ability to plot is available through TAC-Link. So a computer, a PC has to be running with TAC-Link on it, but then it will track. It's just kind of like a pre-canned data acquisition system, and allows you to monitor key features in the tachometer outputs. So the relay status and the speed that the tachometer is seeing. And so you can let the thing run overnight, and you can determine, maybe there's a glitch going on in the process while you're not there, and you can come back in the morning, you can take a look at it. You can take the file and export it and look at it through Excel and do math on it, or MathCAD or something like that. So it gives a lot more flexibility and allows you to either increment or implement that into your process, that function of plotting, or to use as a diagnostic tool if you're having some kind of troubles. The TAC-Troll, because of its front panel and display, we're showing this as the example. The programming for that is just a simple menu-driven, a series of nested menus. We start with the front display here, and before we get into the menus, understand that this is kind of like, before we all went to smartphones, the old navigation keys on our cell phones, you had the up, down, left, right, enter keys, and then 2 function keys. So it's the same thing. If you remember how that worked, you'll do fine with this. The functions change over these function keys. They change depending on what menu you're in and what you're doing. So if you look at the front panel, before you get into the menus, you can show channel A and channel B. You can even configure this to show E, which is the result of an equation that you're performing with the TAC, so you can see that. You can, for channel A, you can define it as RPM, B is frequency, or basically it's a text field, so you can type it in and then it shows up on the display. When you're looking at the display, you go, oh, okay, A is RPM and B is frequency. It allows you to understand the units that you're looking at. Along the top, you see D1, D2, R1, R2, and this alarm status. So in this particular instance, the tachometer is in alarm, and it's D1. It's the digital or solid state relay that's in alarm. So this just shows up as a visual reminder, but it's also saying that the contacts for D1 are closed, and that whatever you have those hooked up to is then energized. In the upper right-hand corner, there's a T. That T shows that it's in tachometer mode. If there was a C there, it's in counter mode. And so that the tachometer can be configured as a counter, so instead of speed and frequency and that kind of thing, it comes up and it says, all right, I'm just going to count. So if you have, bottles going by on a conveyor belt, you can count the bottles and it'll count and register that. You can set your thresholds to that. So if you want a relay to, trigger when you've hit 1500, then it'll go off at 1500. You can utilize the counter mode when you're looking at an encoder, a shaft encoder, so you're counting pulses. If you're counting pulses and you know what the diameter of your wheel that's riding on material, if you know what that is, you can calculate then how much material has been fed. So there's a lot of different things you can do beyond just standard RPM measurement with this. So when you're ready to go into the menus, you'd hit F1, so that's menu, and when you go into the menu, then you get the first menu here. It's asked you want to change the TAC or a counter, so it puts it in that specific mode. There's also a verify and a diagnostics mode that you can go into. From there, if you select change TAC, then it puts you into the next menu, and then do you want to change the input or configure the outputs or the relays or the analog output. And then beyond that, then there's additional menus there. If you can, again, I highly recommend using TAC-Link. TAC-Link is the graphical user interface we developed to work on Windows-based PCs, and it allows you to just type in the information, save it, manipulate it, whatever. It has a main screen that shows input A, input B, the result of an equation, alarm status, all of that, and then along the top here are your tabs where you can then select and do some programming. Here's a shot. This would be the digital input setup tab, and this is where essentially you define how the tachometer looks at the signal coming in. We won't go, this is not really about teaching you how to program it, but there are these boxes. It comes with presets on most of the boxes, and so it's really a matter of editing rather than just coming up with the number, so it makes it a little bit simpler. There are some defaults that we put in here, like logic levels that they conform, and so that in many cases you don't have to edit it. In the upper corner, there's a pull-down menu when you click on Program, and that gets you into things like saving the databases. Do you want to open it or save it? And you can also, the COM ports, whether you're using USB or RS-45. So you got that menu in the corner. Then you have a relay setup tab, and this is for the digital or the mechanical relays. You pull this down here, you get a menu. You select the device that you want to be in. You can tell when you have a hysteresis band, and that visually kind of cues you into, okay, when it's safe, this is when the alarm is on, here's when the alarm is off. You define the relay behavior. In this particular case, it's de-energized below, so that's a fail-safe mode. So all of these things, you configure the relay behavior based on this page, and you configure all 4 relays from here. Here's a shot, we were talking about the capability for plotting. So here, what it does is it shows you time on the bottom, and it shows an amplitude. So it's telling you about speed. You can move a cursor over here, and it's going to give you information about the particular point that you're looking at. So if you're running this overnight, it's going to have, I think it's every second or every 2 seconds, it's taking a measurement. It records all the data from that. You can either look at it graphically like this, or you can export it to an Excel or MathCAD file. We have another tachometer device, which we kind of, this was It was really brought about to be like our old Tactrol 2. And really what that is, it's just a tachometer. It doesn't do any control type function. So it's a display. It shows you what the speed is. It doesn't have relays, it doesn't have analog output. You can configure, you can scale it, but it doesn't really have any control function built in. So if all you need is a display, you just want to know what speed you're doing, then you can use a device such as this. This is certainly a more cost-effective way of going than the other devices, but again, it really doesn't have any other function but displaying a speed. We offer a number of accessories to help you then get this get your project started. If you've got the need for a gear, we offer split gears and solid gears, you know, in specified diametral pitches and tooth count. The solid gears and the split gears can be rebored to fit your shaft. There's some rules and everything. We're not going to go over all the different variations. That's in our catalog for sure. But you know, you can get this to fit a shaft. If you have a shaft that's already installed and you got bearings or something on either end, that's where you'd use a split gear. Otherwise, the solid gear is probably your best bet. We have a number of cable assemblies. Those cables mate with our mill standard connectors that we build onto our sensors. The cables, the cable assemblies, the cable itself is rated for the same temperature ranges as the sensors, so that when you buy the cable assembly, you don't have to worry about whether or not it's going to be appropriate at those temperature ranges. And they are available in a number of different materials, so you can select it. You know, you get different cable lengths, and we can go up to about 50 feet. We have a device called a tachometer transducer. That device has a sensor built into it, and it's a ring. There's really a target in here on a bearing, and the idea is you put your, you know, the shaft gets mounted onto a shaft, and the target rotates because of that. This bar here helps. It can be used to then tie the device so it doesn't begin spinning with the shaft, and then the sensor picks up the signal. The idea is the air gap between the target and the sensor is fixed. It doesn't move, because if you have a shaft with a lot of runout, you can have a shaft that's wobbling all over the place. You certainly couldn't put a traditional target and sensor combination on there, but if you attach this, it doesn't matter how much it's moving around. It will always keep the target and the sensor at the right air gap and give you a good signal. It's good for radial and axial runout situations. We were talking about in the active speed sensor module, the problem with a lot of active speed sensors, even the passive, but the active speed sensors, they can get to a point, if you've got enough cable or capacitance hung on that cable, that it will potentially keep the sensor from even switching. And this can be a problem when you get, you know, over you know, a couple hundred feet on the cable. Depending on how much capacitance you have in there, it could happen within 300 to 600 feet on that cable. This device, you essentially mount in line. So if you have a sensor cable running through, you just cut it and make your connections on both sides. We offer a TTL and a supply tracking version, and that will allow you to drive into, you know, high capacitive impedance in cables running up to about 3,000 feet. So you know, that can be a significant improvement over the standard sensor itself. And again, that's available in TTL and supply tracking outputs. So when you're making that decision, you know, why do I need a DSDA? That's our digital signal distance amplifier. Well, it'll work with any AI-TEK active sensor and many other brands, TTL or supply tracking. You'll kind of begin to see this when the sensor works fine locally on a short cable but fails at distance. So this is, you know, if you're, you know, you move along to that third bullet item down, you know, if you've got, we're saying about 500, in excess of 500 feet, but I've seen even as low as 300 feet if the cable's really bad. You know, if you're exceeding, let's say, you know, I think it's 25 picofarads per foot. If you're exceeding that on the cable, you look at the cable spec, if you're exceeding that, you're probably in at risk of having a problem. So, you know, with two conductors, if you're exceeding 12,000 picofarads, or with multiple conductors, you can go 1,000 to 3,000 picofarads. But if you're above that, you really need to have this device. So, and in the signal frequencies, if they get up too high, that interacts with the capacitance that is in the circuit, and that just makes the problem worse. So any of those times, you know, you're in excess of 500 feet, you got high capacitance, you've got a high frequency application, those are times when you're probably going to need the DSDA. Okay, that's the end of the tachometers and accessories training. If you want more training, please check out the company introduction, variable reluctance speed sensors, or active speed sensor training modules. Thank you.